morning. How are you guys doing this morning? Woo! So I'm Yrieix Garnier. I'm a VP of Product at Datadog. And product management is really all about understanding what the market trends are, talking to you, or customers, or partner, to understand what are your requirements, what are your needs. And finally, I would say the most important is working with our engineering team, making sure that we actually deliver the right solution, the right products to address your needs. And I've been doing this for 20 years and about a bit more than 4 years now with Datadog. So in this keynote, I'm really going to show you kind of how is Datadog unique in that area. But before jumping into this AI era, as we're going to talk about, I want to take a quick step back. Look at what's already been driving a lot of the conversation here, which is the cloud migrations and also the digital transformations. This is really where most of the business needs, most of the business needs today. And I was talking to one of our customers this morning, and they really need to be able to transform to the cloud because they want to have that agility, that innovation, but also some of the cost saving that you have behind this. And if you look at that graph, this has been going on for a pretty long time, but it's really kind of accelerating in the last few years. But when you actually go and migrate to the cloud, do digital transformations, it's also bring an inherent type of complexity into this. You can see on those graphs, this is just like four factors of things which are actually driving that complexity. You can think about the number of team that you have, number of tools that you're using, number of releases, or even like the technology that you're using. All of them, when you bring them together, make it very challenging to go and address and meet those requirements, which for you are critical for your different businesses. So if you take this and now add the AI on top of it, AI is really another big factor of growth, but also you'll see of complexity. This AI here, in the last few years, just in 2 years, we've seen, and this is like market data, people spending twice more on AI. That acceleration of AI is really like impressive, and I think anyone in this room would agree with that. AI is really transforming how we're doing businesses, how we think about it, and how we drive our day-to-day challenges. So the other thing AI is driving also is that complexity. Now, if you can see, we have 2 more charts on the left, and those are growing even faster than the one that we had on the cloud side, which is your number of models that you'll be using or the productivity of your devs are really like exponentially growing. And this all on own makes the complexity of what we do really skyrocket. And that's exactly the problem that we are solving. With Datadog, we actually connect the different software components together. We connect the teams, we connect your infrastructure with your services. We connect all the different kind of complex systems to really make sure that we address that complexity. And we're also doing it in this AI era. The way we've been able to be staying on top of this, being reactive, is actually because we are investing a lot at Datadog. If you look at this graph, this is how much we invest back into our R&D. A bit more than 30% of our revenue is put back into R&D. That means in 2025, like over $1 billion of investment is going back into our engineering team, and we have more than 4,000 people now doing engineering. So this is, I mean, by way of magnitude, much bigger than any of our peers, and that really help us drive that innovations, drive that cycle of releases, and bringing and always keeping up to date with the value we can provide you. Datadog has really been built on that platform, the base layer that you see here, and what we've been doing over the years is we've been adding more and more use cases, supporting more and more value for you on top of that platform. This is really like every year we've been added, and if you like what we'll be doing in this keynote, we're just really going to dive deep into some of those areas and showing you what innovation we've been building and where we're looking at that in the future. But before going there, I want to take one of the announcements that we made yesterday, and I'm sure, I hope a lot of you have seen it, and if you don't, we just announced yesterday that we'll be opening a UK data center in 2026. When we think UK data center, it means a whole region from Datadog perspective, where we'll be able to like ingest your data, process your data, store your data. They all would stay in the boundaries of the UK. And this is really important because we hear a lot of you telling us, hey, I have some specific kind of data compliance. I need to follow some like regulatories, like the UK GDPR or Cyber Essential Plus. And now with this data center in UK, we'll be able to provide you the full feature of Datadog, all the services. This is a whole Datadog region running on that data centers, and you'll be able to access it and really help you go and continue grow your own businesses, but also keep that in the boundaries of UK. And that's a pretty good announcement, and I'm super excited because, you know, I can see the room here from last year to this year more than double, and this is really those needs that are driving us from the business perspective. So that's coming this year, and I hope you're excited because that's where we're building for you guys. So in this keynote, I'm going to go and go through like 5 different areas. The first one would be really around how we drive productivity with AI. Then we're going to talk more about understanding and optimizing your infrastructure. After that, connecting your front and your back end for that visibility. We're also going to spend time on security. And finally, talking about shifting left, but also shipping safely. All those areas will dive pretty deep into what we're doing, what's coming, but also, I think more interesting, you'll hear from customers what they've actually been doing in those areas. So we'll bring some of our customers on stage in this keynote this morning. So let me start and begin with this AI and how we drive productivity with AI. In AI really is all about the data. And at Datadog, we have over like 30,000 customers, and that really can enable us to develop the most comprehensive data set across every use cases. Here, you can see we have about 62 of the top 100, of the Fortune 100, 8 out of the 10 kind of AI-driven company, which all are building their solution with an AI observability mindset. And when I say this is not just like getting telemetry, but this is really understanding how we monitor their system, their processes, their business data to really get the right value out of this. And at Datadog, when we think about AI, we think about it in 2 ways. We think about AI for Datadog, how we're going to help you do your RCA as fast as we can. And we think about Datadog for AI. How do you apply observability for your AI-powered applications? Let me start with the first one. How are we doing AI for Datadog? Here, it's really about all the numerous kind of AI agents that we've been launching to really help you surface like the context, identify problems, or recommend fixes if any issue arise. In the traditional world, and this is something which we, I think, all lived throughout our careers, we've seen that incident response is usually very, very fragmented. It's complex, a lot of manual processes, different teams, different tools. The context is like in dashboard, in tickets, different threads. Very hard to make sense out of it. And at the end of the day, what it does, it like just make your response kind of slow and usually fairly costly. It's like the team have to spend time into like war rooms and so on versus like innovating, which is really where you would want them to be. And then also like requiring them to use like these different contexts, different tools, so very hard to really go and communicate. And this, when you do that in production, this is always that constant loop. You always have like introducing new change because you have to bring those changes, but those changes now do introduce potential stress on your system. Then you have to identify the stress, and from there, kind of scramble to get how to go and fix it. This is actually very siloed, repetitive, and fairly slow. This is what we actually already solve at Datadog. We really help customers close that end-to-end loop and really making sure we continuously kind of monitor your system for the sign of stress, but also that we like give you the right information to detect those issues and also the information to remediate those issues. What we're doing now in that AI era, and you can see we're shrinking that circle, which means we make it even faster. We're actually accelerating all of those different steps. In the middle of this, you have that logo, which is our Bits AI. This is our like AI logo at Datadog, and this is where Bits, that solutions, come into play to really help you like do that detections, investigations, remediations really, really faster. And we have amazing results for that. But instead of like spending time on this, what I want to do is kind of show you it live how it works. So I'm going to walk you through kind of a quick demo of Bits AI. So in this case, I'm actually inside the Datadog app, and I'm using kind of Bits AI. What's happening here is we have an incident, a monitor with triggers, and Bits AI is going to automatically go and leverage the context of that monitor, understanding like the different dependencies, the runbook, all the different metrics which is behind it, and start a discovery. When it does start a discovery, it's going to start to build some hypotheses. It's going to start those hypotheses and really go and start to investigate each of them. The goal is to be able to either validate the hypothesis is correct, invalidate it potentially, or keep it non-conclusive. When we do this, and Bits is really going to go and dig fairly deep into this to be able to solve those multidimensional problems, and it will really build that evidence and understand what's happening behind the scene. So here, it's going to be able to go and look at your different logs, at your traces, but also all the supporting kind of telemetry behind it. It's really showing all the relevant tool calls it's actually doing, so it can go and get data from your source code, from your real user monitoring, from your network path solutions, but also potentially from third-party observability tools. And here, this is where Bits SRE, in this case, kind of correlate and identify and validate all those hypotheses to be able to come, when you're done with that pass here, to the root cause of the issue. And when it analyzes the root cause, this is something you can go and share with your different teams through like either Slack or MS Teams or any channel that you want. You can take action out of this, but it really show you how it came to that RCA. It's going to really show you that, hey, I understand all those hypotheses, why I made those hypotheses, what are the tool calls that I had to do to get there, so you have confidence. Because one of the biggest, I would say, challenge of AI overall is understanding what it does, so you can actually really feel confident about what you're getting out of it. But also, last but not least, to build that confidence is also the ability to go to this agent trace. The agent trace is really kind of the every step of reasoning that agent is actually doing, understanding what has been done, what are the different tool calls, the different durations that those calls have been taking, and keep that for your historical records. So you can know what's been happening for those incidents, but also you would know that, hey, if something arises on the same nature, you know how to go and to fix it in the future. What you can also do, and you see it on the left-hand side here, you can also interact with Bits. So you can actually add questions to Bit. You can add more context if you need to. And finally, you can go and even add your own Bit MD if you want to add additional context on top of that. So that's Bits AI in a nutshell. Pretty quickly, but that's super impressive. We have amazing results. And the most exciting part of this is GA. You can go and use it today. If you're using Datadog, just go to Bits, and it's going to give you those RCA automatically. The second part I want to talk about is that Datadog for AI. In this case, this is all about when you are actually building your own LLM-powered applications, your own autonomous agents, and how you need to observe those solutions as you're putting them into productions. The idea here is that we'll be able to support the full stack of those AI solutions. We'll be able to understand what's happening from the GPU perspective, making sure that we understand, hey, how much you utilize, what's your cost, but also how GPUs are optimized compared to the different workloads running on top of it. If you look at the AI layer, the model layer, in this one, we'll be able to support if you use a hosted model, if you have a fine-tuned model, or if you build your own models, we'll be able to support them to understand what really that deep visibility into it, understanding what are the cost, but also those in and out, input in and out of the different models. And finally, when you look at the application on the agent layer, we understand that very complex type of interactions between different agents, between different applications, and really allow you to understand and have that visibility on top of those solutions. In this one, I'm just going to show you that one slide here, which is our LLM observability, which really helps you understanding those model performance, going into the full prompt lifecycle, the different chain tool that it's calling, the intermediate input-output. It also allows you to kind of monitor the operational performance, like how those models are doing, performing, how many tokens they're actually consuming, are they the right cost that you have? And finally, you can also evaluate the quality and safety of those models. You can also here make some experimentations, decide what model you do want to use. But instead of me talking too much about this, what I'd rather do is introduce one of our customers, Mark O'Neills from Virgin Atlantic.
Good morning, everyone. So implementing customer-facing AI is daunting, especially when brand reputation is so important. Today, I'll be explaining how we safely launched our customer-facing AI assistant in just 90 days. So I'm Mark, I lead our applied AI engineering team at Virgin Atlantic. So just a little context before we continue. Virgin Atlantic is a long-haul premium airline flying around 5.5 million passengers every year to 29 global destinations. Our brand is built on service, personality, and trust, which means mistakes can be very visible. But it's our people that really set us apart. Across the entire journey, when customers meet our people, satisfaction scores are at their highest. But the travel journey is complex, and it's not always possible to have direct contact with our people. And if you're anything like me, you'd probably prefer self-serve instead. So in the era of AI, how do you replicate a great customer experience in the digital world? Introducing Concierge, our new AI customer assistant. It supports 4 core journey types: help Q&A, flying club queries, flight search, and holiday discovery. Customers can ask practical questions about their trip, from what's my baggage allowance to what do I need to know about traveling with an infant. It understands all about our flying club and can explain the benefits really clearly. And for trip planning, we didn't just prompt an LLM, we observed how our frontline teams support our customers and then built those patterns directly into Concierge. We developed Concierge with OpenAI, who said what we've built is the first for European airlines, and we're very proud of what we've delivered. So when we started building Concierge, we asked what could go wrong. First, providing customers with the wrong information. LLMs can hallucinate. If you give incorrect baggage rules, visa advice, or flight details, that's not just a bug, that's a broken journey. Second, PII leakage. Like many businesses, airlines handle sensitive customer data. One slip, and you're not just debugging a model, you're handling a GDPR incident. Third, not authentically being Virgin Atlantic. Even if the answer is correct, if it sounds generic or robotic, we've diluted the brand. Tone drift is brand drift. And fourth, brand reputation. Users will try to break it, some playfully, some maliciously. If the system can be manipulated, that's a headline waiting to happen. So, given there is so much at stake, we decided our anti-goal was simple. We don't want to be in the press for the wrong reasons. Every choice you'll see next exists because of these risks. And we decided very early on that we'd constrain the scope. We decided that there would be no PII allowed in the system, so we don't allow the model to access or process personal customer data. There's no logged-in state, Concierge has no account context, no booking retrieval, no session memory tied to identity. And we only support read-only operations. Concierge can surface information, it can guide, but it can't transact, and it can't change bookings, and it can't update account details. By limiting the scope, we reduced the blast radius. If the model hallucinated, the damage was constrained. If the tone drifted, we can correct it. If users try to break it, we can observe safely. From day one, we decided safety, security, and observability as a non-negotiable foundation. The entire team, and more importantly, the stakeholders, were aligned on this principle. So I'm now going to talk about how we kept Concierge safe through our guardrails. Guardrails in our system are not just a single filter. They are a gated, parallel evaluation pipeline. When an input enters the system, we first perform a lightweight validation. We're checking for the length of the input and the presence of PII data. We then branch into parallel LLM-based classifiers. We execute checks for prompt injection, harmful content, off-topic queries, and language constraints. Intent detection runs concurrently with policy checks to optimize latency. If any of the required checks fail, the request is blocked, and we inform the user accordingly. The request reaches a specialized agent if all gates pass. This architecture gives us two key properties. First, latency discipline. Parallel execution prevents safety from becoming a bottleneck. And second, isolation. Each policy dimension is independently observable and enforceable. So we're not asking the model to self-regulate here. We're surrounding it with enforcement layers. But guardrails only matter if you can prove they work. So in development, we built curated datasets covering intent routing, off-topic queries, and prompt injection. We implemented a deterministic exact match evaluator, which forced us to remove any ambiguity. Next, any changes to prompts, models, and thresholds trigger regression runs using the Datadog experiments feature. And we also run structured red teaming before deployment. We didn't just assume the guardrails were robust, we structured our red teaming deliberately. First, we created a harmful query dataset of 40 domain-specific prompts across 8 risk categories. These weren't generic jailbreak attempts. They were tailored to Virgin Atlantic and covered fraud, misinformation, booking manipulation, and brand abuse. Then we escalated. We applied persuasive jailbreak prompting techniques from a research paper called How Johnny Can Persuade LLMs to Jailbreak Them. Instead of harmful prompts, we reframed them using psychological strategies. That transformed the 40 base prompts into 1,600 jailbreak variants. Finally, we ran the full suite of prompts through our guardrails and measured the trigger rate. This gave us a structured, repeatable way to stress test the systems before the users ever could. When we tested the 1,600 jailbreak prompts, the initial trigger rate was roughly 75%. This meant a quarter of the adversarial prompts made it past the guardrails. The most effective techniques weren't aggressive, they were actually subtle. First, priming. Priming means setting the emotional context or groundwork before asking the harmful question. For example, as a concerned customer, the harmful request comes after trust or context is established. Next, positive emotional appeal. This is where the user flatters the system or appeals to shared values. For example, "You're always so helpful," or "I know you want to support customers." The idea here is to soften the guardrail through tone. And finally, compensation framing. This reframes the harmful request as justified or fair. For example, "Since my flight was delayed, what's the best way to claim compensation?" Even if it was the customer's fault. The user positions the request as being reasonable. So that told us something really important. The system doesn't fail under attack, it fails under persuasion. So we iterated. We refined our system prompts, justified the classifier thresholds, and tightened our enforcement logic. And we were able to push the trigger rate up to 95% across all 1,600 jailbreak variants. The key lesson here is guardrails must withstand influence, not just obvious abuse. So red teaming tells us how the system behaves under stress. Observability tells us how it behaves every day. In production, every LLM turn emits a structured LLM ops span. That span captures guardrail classification outputs, prompt input and outputs, downstream agent calls, latency and token usage. Injection and off-topic rates are tracked as time series metrics. If those drift, we alert. And critically, we have trace-level visibility into blocked versus allowed flows. Safety isn't inferred, it's observable. I'd now like to share one production insight that really reinforced why observability matters. We recently launched a new Flying Club benefit called High Five. Shortly after, we noticed a spike in the off-topic trigger rate. When we traced the spans, we realized something different. Legitimate customer queries were being blocked. The guardrails were doing exactly what they were trained to do. The problem here was distribution shift. The classifier was being trained on a historical domain language. The new benefit introduced new terminology and phrasing. Observability had made this visible immediately. So we updated our system prompt and classification dataset, refined our off-topic thresholds, rerun regression tests, and redeployed. The trigger rate returned to baseline without weakening enforcement. The lesson here was simple. Guardrails must not just defend against malicious users, they need to evolve with your product offering. So I'd now like to recap on our key learnings. Building brand-safe AI isn't about just adding a moderation endpoint. It's about constraining capability before expanding it. Start narrow, constrain your blast radius. You need to design guardrails as enforceable system boundaries, not just content filters. Stress test those guardrails in ways humans actually behave through structured red teaming. And treat LLM behavior like production software, testable, observable, and enforceable. And finally, get external validation. We red teamed internally with our delivery partners, but got third-party validation independently of that testing. This is how we've protected our brand, and that's how you ship safely at pace. Thank you for listening.
Thanks. Isn't it amazing to hear from our customers directly? And I can tell you, Virginie is great. I flew with Virginie to come here, so really love what they're doing here. So next, I want to go and talk about that second kind of area, which is how we can really help you understand and optimize your infrastructure. This one, very close to my heart, because I've been working on this for like over 4 years. We're going to deep dive a bit into infrastructure monitoring. And in infra, it's all about kind of the challenge you have today, which is the lack of visibility into those very ephemeral type of infrastructure components when you have some on-prem, when you have cloud, when you have a lot of different tools that you have to go on to use, which is making that visibility really highly fragmented here. So at Datadog, we do support that solutions, and we really change that with our infra monitoring solutions. We allow you to really observe kind of everything everywhere and have that one platform component, which is going from your, I would say, traditional host to your containers, to your serverless, your network, and even your cost visibility, all of that kind of in real time in Datadog. The other thing that we've really been investing a lot is actually our support for open telemetry, that native hotel support. And we are one of the top contributors of hotel, and we have that native support of it. So all the hotel semantic, we do support them in Datadog, so you can very freely, easily choose if you want to use Datadog or hotel to ingest and send the data, different data to Datadogs. And finally, what we've been also investing on the infra side is the last kind of part here, that's automated insight, where we're adding, again, more and more AI into our product to making sure that we give you those correlations of what's happening in your environment to make sure you can cut through the noise and really accelerate the resolution times. So if you look at infra monitoring, what we hear a lot also is how can I bring my cloud and my on-prem together? I'm sure a lot of you already know what we do for the cloud, but you're also still doing your migrations from cloud to on-prem. So for the on-prem side, we do support today all your different on-prem servers, your VM, but also your on-prem networking, your wireless access point, your end-user devices, and even the edge infrastructure that you have. All of that inside the same solutions with the same visibility on-prem that you have on the cloud workload. So that really allows us to give you that automated view and have that full visibility across your entire estate. The second thing I do want to talk about is how we bring AI into infrastructure monitoring. Here, this example is about our Bits AI Kubernetes remediations, and it's really about helping you detect and remediate very quickly what's happening inside your Kubernetes environment. So at Datadog, we run a very large Kubernetes clusters, I mean, tons of clusters on Kubernetes, and we do dog food, which means we use our own tool or on our own products. So we have a lot of expertise behind this. But what we've done, we've added AI on top of it. So now we can really help you automate the understanding of what's happening inside that environment, give you like the right recommendations, but also apply fixes on top of it. Fixes being changing your environment, creating a PR if you need to, or run a workflow that you want behind this. That really helps you reduce that MTTR, making sure that you solve those problems as fast as you can. So that's a quick sneak peek around infra monitoring. I also want to talk a bit about log management. And log management, I would say, is kind of the perfect storm those days, because we've really seen the volume of log exploding, more than 50% year over year of logs, but a lot of those logs are like really hard to query, or you even sometimes have to keep them into your own kind of layers because it's like too expensive to send them to a log management solutions. And this is what we also want to solve with our kind of modern log management solutions. Here, we have that solutions to really being kind of future-proof, to make sure you have that full-stack logging, that any scale without really compromising, but still giving you the right speed, security, but also the right cost behind it. So we also bringing AI to kind of accelerate the RCA, and this is what we've been talking about before. but also bringing logs between what you do on the operation side, observability, and also on the security side, because the logs will be the same, that you just treat kind of differently between the two solutions. And finally, we're also helping you optimize that logging cost at scale, and I'll dive a bit deeper into this. So what we've recently launched to is what we call this archive search or frozen log. This is really, as your volume of log is actually growing, you need the longer retentions. You want to make sure you have that compliance, but also the cost support behind this. So with archive search and frozen log, we really give you that control over the long-term data. What you can do here, you can search inside Datadog in the same place, but you can search across what log have been really kept into your own archive, being flex logs, or even into your own cloud storage, if you're running that in an S3 bucket. And here, you can do this without rehydrating your different logs. And that's really a simple query, running actually pretty fast, and stream that results back into Datadog. So here, it really allows you to go and maintain the logs longer, and making sure you have the right cost for them. And here, we have a customer example, which is Okta, the most trusted kind of identity provider here. And they actually been using Datadog to unify all their different logs, but also metrics and traces across all their clusters, which really give their engineers kind of that single source of truth. And they actually, by adopting flex logs, being able to retain all their logs, and really like with a cost that was kind of in control from their perspective. And they actually did save quite a lot because they have the right information, so they can fix their issue a bit really faster here. So if you look at logging, we support that full spectrum of logging use cases, from the operational log from your productions, but also with flex logs, we can support your transactional logs, your security, or even your network logs you have to retain longer, and also the log you have to really kind of archive and retain for a very long time, like your audit and config logs that we can now support with the frozen tier and archive search. So now I want to jump into the next chapter when we go and connect that backend and that front end. But I'm sure you heard enough of me for now, so I'm going to invite my colleague, Hugo Kaczmarek, to come and talk about that.
Hello, everyone. My name is Hugo, and I've been a PM at Datadog for a bit more than 7 years. I've mostly been working on application monitoring products, and the reason for that is when I was a junior PM, I used to love designing and coding myself features, and then watch our users play around with them. But over the years, I've stopped doing it simply because it became too complex and I wasn't good enough. But lately, with the rise of coding agents, I've been able to do it again and find that joy again. But having people like me use coding agents brings a whole set of new challenges for companies, and I'll walk you through those today. First, let's start with our core pillar of observability, that is application monitoring. This is a view of a typical system. It has a front end, some databases, and some backend services. And the key thing is, when something breaks, you have multiple services involved. That's why it's very common that you have a lot of developers on a call that are trying to solve through an incident. And it's a huge waste of time. So with the APM, we offer you 3 layers of observability to try to solve for that problem. The first one, that we call service observability, is essentially the high-level view of your system. It contains the map that we just saw, as well as a set of high-fidelity metrics that we call red metrics for request, error, duration. And they tell you about the health of your applications and endpoints. Now, let's say one of those goes up, like latency. Then you need to investigate. That's when you go into distributed tracing. You need to find a representative request that is representative of the symptom of your problem. By looking at the trace, you quickly identify which service is responsible for the slowness. And that's when you move to the third layer. We've built over the years a set of low-overhead profilers that can run all the time. And I can tell you at Datadog, we do run them all the time, all day long, on all applications. And these profilers tell you which lines of code take time and resources. So then you identify the faulty line or the faulty method, and you simply ping the dev team that is responsible for that. Now, this flow that I just presented is very reactive, and it's been there for years. And sure, we've hyper-optimized it, and Yrieix presented Bits AI SRE. We have our SRE agent that can do that in minutes. But I often hear from you, hey, Datadog, you've got all of that data. Why can't you tell me in advance which services are likely to break? That's why we've built APM recommendations. And by the way, it is GA as of a couple weeks ago. So to build these recommendations, we leverage our domain expertise of observing and running thousands of technologies. Then we comb through all of your data to find architectural flaws that may break your system in the future. For example, N+1 queries, missing database index, faulty garbage collector, etc. Then we group them by team, triage them by order of importance, and send them to every team. At the end of each of those, you even have a pull request ready to be sent to fix them. Now let's talk about the front-end side. I hear two main recurring themes. The first one is, how can I make sure that I'm not losing any money and that I'm actually making some business? And two, how can I make sure that I'm shipping faster? We're trying to answer both of those with our DEM suite. So digital experience essentially touches your user satisfactions, your user retentions, and ultimately your business. And we've seen a shift recently from technical observability to functional observability. In other words, what it means is if the CPU on one of your machines is high, but your users are not impacted, is it the top priority thing to fix? On the other hand, if your users cannot pay, yes, sure, you should focus on that right now. We also see on the positive side that executives want to prove the ROI of the features that you ship. And that's why we have a whole set of products that are coming to market called experimentation that will allow you to run A/B tests and measure the lift of the features that you ship. At the end of the day, it all comes back to the same thing. Tie what I'm doing to the business that I'm making. And so our DEM suite solves that. We can detect friction early. And because we look at every action, every click, every drag and drop that the user makes, we also can relieve them through session replay, so you can experience exactly what your users are experiencing. We allow you to make better business decisions. So let's walk through a quick demo of that. We'll see a couple of investigation flows. We'll see how to measure the lift of shipping a new feature. And finally, we'll see how to be more proactive. So here in product analytics, I'm looking at a funnel conversion drop. To investigate further, with a couple of clicks, I can create a funnel that is representative of my checkout flow. At each step of the way, I can see business and technical metrics of what's happening from the users that are either converting or dropping out of the funnel. Now, because product analytics and real user monitoring are built on the same type of data, from each step of the funnel, I can also jump into individual sessions that may be representative of the problem. And I can watch a session replay of what happened. Now, I notice here that there is an error. And so I can just simply ask our preview coding agent called Bits AI Dev to generate a fix for me. So far, we've looked at the typical investigation of an issue. But let's say I'm a PM and I want to ship a new feature. For example, I want to have bigger images on my website. I can just create an experiment, so an A/B test, with 50% of the population exposed to the new images and 50% staying in the control. And then Datadog will just compute the technical metric and the business metric to measure first if you haven't broken anything, and 2, how much revenue you're generating. And then you can see on this graph here, you have confidence intervals to allow you to make good decisions. So this product is coming to GA in around a month, and we're super excited about it. Finally, on the proactive side, I can use synthetics to create a browser test and API test that mimic my flow of checkouting. And then I can run these tests on production and on staging with the goal to find problems before they reach production. So we've seen similar themes with front-end monitoring as with APM, faster root cause analysis, tying everything to the business, and being proactive. Now, on the other side of the spectrum, if we look at our data pipelines, imagine you're trying to book a ticket from New York to San Francisco, and then you see that the business class price is actually $15. So you jump on the occasion, and that actually happened, and you have hundreds of people that booked such tickets. Now, when you're the airline, you're thinking, well, either I revoke the tickets, but then I take a huge reputation risk, or I just lose millions of dollars. And so we have these data issues that are happening everywhere, and they are also heavily mediatized. So the typical problems are the data jobs run at night for hours at the tail end of every pipeline. And so that's why when there's a data problem, you are the last one to know, and it's usually way too late to fix them. You have to rerun all these pipelines, and it takes hours. The second issue is that everything is interconnected. If you think about the service map, like the data map, the map between all your tables and your job, is even more of a spider web. And finally, these jobs are expensive. They take hours to run, and there's, according to our customers, very poor visibility into the performance and cost of those. So that's why, also as of a couple of weeks ago, we released data observability. The view that you can see here is what we call the data lineage. It represents the dependencies between your tables and the jobs that are running to generate them. And with that view, you can catch issues early and pinpoint exactly the job or the table that is responsible, let's say, for data corruption. And also with that view, you can understand all the dependencies that have been corrupted afterwards. Finally, we also give details about performance of each of the jobs so that you can identify cost savings opportunities. And now, I would like to introduce Adam Hope from Entain, who's going to talk about his own experience of running pricing pipelines.
Brilliant. Wow. Good morning, everyone. My name's Adam Hope. I'm the Global Trading CTO for Entain. We're one of the world's leading sports betting, gaming, and interactive entertainment companies. We have over 30 brands, we're in about 30 regions, and there's 29,000 colleagues. So every click, every bet, every customer moment is powered by data and trust. When you operate in one of the most regulated industries on the planet, trust isn't optional. So we're one parent company looking after sports betting brands which have been around for a very long time. Now, you might recognize some of the newest brands here with some of the oldest bookies in the world. So believe it or not, this year is the 100th anniversary of Coral. So Joe Coral set up shop in the summer of 1926 with 2 runners in a billiards hall in Stoke Newington. This was the start of an exciting new import from the United States, which was greyhound racing. However, Coral isn't the oldest bookies that we look after. Ladbrokes was actually founded in 1886 and started life as a commission agent for horses being trained at Ladbrokes Hall in Warwickshire. Now, sports betting has come an awful long way since then, so I'm going to walk you through how modern sports trading works today. So let's just cover off what trading is. So in a traditional sense, you'd be trading actual goods and services. At Entain, we're trading betting opportunities. Now, sporting events are beautiful, semi-coordinated chaos, and it's either really high speed like basketball, medium speed like football, or a slightly slower pace like baseball. Now, the betting opportunities on markets that we provide are for you to take advantage of that chaos and bring even more excitement to the thrill of watching your favorite team. Now, will your team take the win, or will your favorite player hit a home run? Now, producing these betting opportunities via our trading pricing pipeline, which is generating the odds, is what we do in trading. Even though Major League Baseball is a slower pace than basketball, it still requires precision and speed. Every single pitch is a physics event. So even NASA have modeled the physics of pitching in baseball. And it's worth a look at NASA's site if you want to try some interactive physics baseball modeling. Now, there are thousands of micro interactions per game, and it's a technical and mathematical challenge to determine what matters, what doesn't, and how to use that to predict the outcomes. Now, we have an awful lot of inputs to the mathematical model, such as the current state of the game representing every single combination of runners on base, and also the number of outs. But we also consider decaying factors, such as pitcher fatigue, like how long has he been pitching for? We do batter versus pitcher matchups, and we track the outcomes of previous times that that batter and that pitcher have played against each other and what the outcomes were. The weather also has, surprisingly, quite a significant impact. The humidity in the stadium affects ball grip and therefore impacts spin rate and velocity. And it's also non-linear throughout the game. Like the wind, for example, gusts at different heights and can be very location dependent. So the wind itself can be a major contributing factor to actually preventing home runs. Now, one of the major impacts of this is the Chicago Cubs at their stadium, Wrigley Field, which is on the banks of Lake Michigan. And lower air density also makes the ball travel further, and that means more home runs. And this can be easily seen at Coors Field, which is the home of the Colorado Rockies, where the stadium is a mile above sea level. That difference between sea level and the mile above is a 9% velocity increase for the ball. So how do we take all of this data to calculate the odds and what makes us unique in the way that we do this? Now, pre-match pricing before the game starts, so when you see the event come up on the page and you're like, I'm having a bit of that action, this is going to be great. Now, this is what makes us unique, because we're a price generator, not a price modifier. So what most sportsbooks do is they take input from other global bookmakers to create a baseline view of the odds. And they use that as an input into their mathematical models. And that's why you'll find that most sportsbooks have very, very, very similar pricing. What we do differently is that we've actually got about 17 years of sporting data sat in a massive database. And this is about individual player performance and all the past histories and the matchups, multiple matches they've done in multiple stadiums, in mixed weather conditions, different years, different players. And we use all of that data as input parameters to our mathematical models. And these are stochastic Markov chains. And we predict the outcome of what next pitcher, next batter is going to do and how they're going to perform against each other. We then collectively join all of this data together to create the team outcome probabilities. And that's why we can go to the market with odds which are more favorable for our customers and yet still have confidence in the predictability of the outcomes. This is how we produce the odds ahead of the game, but the fun technical challenge, the interesting bit, happens when the game starts. So for the majority of the sporting events, we actually pay from a direct feed out of the ground itself, out of the stadium. So we just have a person essentially there from our feed providers with a tablet, smashing in play-by-play what's exactly happening on the game. And this is way faster than anything else, right? So we don't take feeds from television, and I'll talk about that a little bit later on. Each play is sent to us directly, and from that moment, we start the timer for our end-to-end SLAs. So this is a high-level view of the pricing pipeline itself. Now, we take in feed provider data and transform it into a standardized model. We then pass this to the stochastic Markov chains, and this does 100,000 simulations of what we think is going to happen next for every single betting opportunity for that game. Now, this is what produces the change in the odds. And we do all of this from getting notified of the new game state to outputting the new prices in under 400 milliseconds. I'll let that sink in for a moment. Game state changes, 100,000 simulations of what we think is going to happen next. We publish new odds for several thousand markets for you, our customers, all to bet on in under 400 milliseconds. And what does that look like? Here's the MLB tracking dashboard specifically, as you can see. We're monitoring the end-to-end latency through this using open telemetry, which I'll cover later on. But why does it matter? Why does 400 milliseconds matter? What happens if this is 4 seconds? So the major impacts from latency in the pricing is exposure to sharp bettors and a poor customer experience, both of which create a loss in revenue. In baseball, the most volatile and arbitrage-friendly markets are the ones that move in real time. And these are the next pitch result, like strike, ball, and in play. And this is the high-frequency trading for MLB sports betting. Also, the outcomes of an at-bat, like what's going to happen next? Like, is it a strikeout, a walk, a hit, or a home run? Now, latency in the pricing pipeline means that we might accept bets on somebody who's actually at the game, right? We might be actually accepting bets on something that's already happened. That's why we don't take the normal television feeds as input, because they vary from 19 seconds after the fact to 62 seconds after the fact. That is an age. Now, in that situation, we're essentially a global free ATM, right? We're going to pay out a guaranteed percentage of whatever you put in. This is not ideal for us. However, everybody else would be very, very happy about that fact. So to try and prevent this happening, what we would normally do is we just suspend the market, we just stop it, we just shut it down. But that stops the customer from getting their bet on. That creates frustration, and when that happens, the customer just moves to another bookie, and we lose that revenue. So for the best customer experience, what we need to do is get the markets out quickly in front of the customer as soon as we can and leave it available as long as possible. That's what latency means to us. This gives our customers the best chance to get their bet on in the action, which means we turn that into this. So in trading, we have about 150 plus services in the pricing pipeline. The data flowing between them is driven mainly by Kafka. Now, to track our latency, we're heavily invested in open telemetry. So every service that we have is auto-instrumented. We send open telemetry traces and metrics in a standard way via collectors. The collectors allow us to be able to dual send data. You can send it to on-premise, you can send it into cloud, you can send it wherever you like. And that's the way that it allows us to have this flexibility within our observability framework. Now, the traces and metrics are in every part of the data flow journey, from our incoming data feeds out of the stadium to our customer sportsbook and our hands of all of you wonderful people. And we use data streams within Datadog to provide clear insights into the pricing pipeline. We set alerts on Kafka lag straight into Slack and our incident management system, and it allows us to investigate any outliers within the flow of data. So for our engineers investigating issues, they get a Slack notification which links them straight to this within Datadog. They can visually see where the tolerances are breached and lag increases on Kafka. So Kafka lag increases when an upstream service produces way more data than a downstream service can actually consume and deal with. This creates extra latency in the pipeline, and it's a vital metric to track for us. Now, one of my favorite sayings is data dispels disbelief. Now, we actively encourage our teams to leverage as much near real-time data as we can realistically process. But it's a lot to handle, and Datadog provides a great way of bringing all of that correlation together. And this is to ensure that the creation of the odds is performant, compliant, and reliable. And when optimizing for very low latency, a great place to start is using tracing and open telemetry to see the timings between each service. To give you an example, this is probably about a week ago, and analyzing an OTel trace directly in Datadog allowed us to spot an issue with sending data into Kafka. Now, When scaled properly, Kafka itself will do hundreds of thousands of writes per second. So we know a delay of 50 milliseconds sending it to Kafka is wrong. How wrong we needed to figure out, but we knew that that was an outlier that we wanted to be able to trace down. And this is probably down to our way that we've configured our application, a misconfiguration, the way that we've set it up. It's something down to us on our application. It's not Kafka. This is not a Kafka problem. So we had to change a few of the settings to be able to do it. This is what we changed within the producer configs. Now, this works for us. This may not work for you. I'm not suggesting that everybody just goes ahead and flips some config and goes, woohoo, I saw this at Datadog. So, linger millisecond 0. This means that Kafka will not batch. It will not wait around for anything. As soon as it gets a message, it's sent. The max in flight 1 means that it's doing them singly. It's not doing parallel sends. It's not doing anything. They come in sequence. Obviously, sequencing within sports data pricing pipeline is absolutely key. Socket nagel disable true. This is actually a really interesting one. Now, this actually started live as RFC 896 back in 1984 by John Nagel. And John Nagel wanted to be able to help out the fact that people had open telnet sessions and they were having to deal with every single key press that went through on the telnet sessions. And it would send a byte of data. And what this does is more batching. And you might actually see this on your operating system as TCP no delay. That's essentially disabling this flag. And socket keep alive true. This is obviously just keeps the socket warm for us to reduce spikes in renegotiation. But what difference did those changes make to our service? By leveraging Datadog to provide this level of insight into our code, we have this front and center in every engineer's hands we can provide them. Now, the insight that they need to find the nuances, the minutiae, the tiny little bits within our pricing pipeline that really matter to us. So we reduced Kafka send with a config change from 50 milliseconds to 649 microseconds. Now, for us, that's a difference about being able to provide 200 markets per game, betting opportunities per game, into about 1,600 markets per game. Now, that creates an awful lot more betting opportunities for our customers and a better experience for them. Unlike our trading models, which are all about predictability, observability is about understandability. Since starting our partnership with Datadog, we've created a greater understanding of what our services do under load, all in a single view with consistent alerts when we breach thresholds. Now we have correlations and investigations, as you've seen, supported by Bits AI. Now it speeds up incident investigations and helps us track down and find latency issues. This next level of observability means that we can go from an issue in production to a production patch in minutes and not days. So I hope this has given you a glimpse inside the world of high-speed sports trading, where a single stale price in our pipeline created through increased latency can mean a real-world loss of £5 per millisecond. So at Entain, milliseconds matter in everything that we do. Thank you, and I'll hand it back to Hugo.
Thank you, Adam. Quite impressive to see all the machinery behind a single bet. Now let's talk about our fourth pillar, that is security. I'm sure you've seen on the news, AIs are getting so much better, so much smarter at attacking systems. And because of that, security is now more top of mind than ever. But it has a couple problems. Devs spend way too much time on security tasks. That's because detecting an attack requires to comb through gazillions of logs to try to maybe identify one single attack. And if you remember what Yrieix was saying, log volumes are skyrocketing every year. As a result of that, it takes, on average, a little bit less than a year to detect and remediate attacks. And that's where we come in. We have all the observability at the code level so that we can be much faster to detect. With what I presented with digital experience monitoring, we can also help you focus on the attacks that have the highest potential of impacting your users and your business. So we can prioritize those ahead of the others. And finally, yes, AI is very good at attacking, but it's also very good at remediating. And so we can automatize that remediation process. And it pays off. We're excited to say that 8,500 of our customers are using our security products, and 1 out of 5 Fortune 500s. Now, we have in preview our Bits AI security analyst, which is the equivalent of the SRE agent, but for SOC teams. So what it does is quite simple. We autonomously conduct every investigation that is worth making, and then we simply generate a fix or a path to remediation. And as a rule, as we develop each of our AIs, you have a full traceability of the reasoning of the agent, so that you don't need to blindly trust what the AI is telling you. So similarly to Bits AI SRE, the security analyst becomes your always-on SOC assistant. Now, on the compliance side, I'm sure you know that in EMEA and in the UK, compliance frameworks are very sparse and very diverse. And so that's why we've made it a focus to create more than 100 rules so that you can map to your compliance needs. Rules both in terms of posture management as well as of sensitive data scanning. All along this presentation, we've talked about developers and how to make sure that they can spend more time shipping. Of course, we've seen it. With coding agents, we can speed 100x coding. But there is one problem that remains. You cannot ship faster today, because the validation that is required takes way too long. And so that's why we've made it the focus to help developers in that regard. And so that's the left loop that you can see here. How do I have a fast feedback loop between what I just developed and what my production is telling me is happening? Over the years, we've built a couple of products in that regard. And today, I will focus on 2 of them that are fairly recent. When you think about control to release software, there is nothing better than feature flags, because you can decide who you give access to your new features to, and you can progressively roll out. Now, today, developers face a false choice. You either move fast or you break things. And so let's say you ship something bad. You realize it, and then you have to generate a fix. You go through CI, and let me tell you a secret. Everywhere, CI is not so great. Even at Datadog, where we have all the tools you can think of to monitor it, to optimize it, it's still slow, it's still flaky, it's still a pain. So how do we solve that? Well, with our suite of products, we actually remove that false choice, and now you can move fast and break nothing because there's this fast feedback loop between the development and the production. So I'm super excited to say that as of a couple of weeks ago, our feature flagging product is GA. We are the first observability vendor to build a feature flag product, and the synergies between observability and feature flagging are quite obvious. Because, as you can see on the animation here, you can create a rollout plan starting from 1%, 10%, 50% until full rollout. And at every step of the way, you can implement automated gates that look at both your technical data and your business data to make sure that everything goes well, make sure that you haven't introduced new friction points, new errors, etc. Then at the end, let's say you run it for a couple of days, you see that everything is doing well, you can just fully roll out. Now, let's talk about the other piece, the MCP server. We all know that devs want to stay on their tools and never leave, and so the tools now are coding agents and never leave them. So I'm super happy to say that as of yesterday, our MCP server is GA. And there's no need to tell you why. There's massive adoption of coding agents. But controlling them remains a problem. I'm sure you've all seen coding agents going off rail, and you're like, stop doing that. So there's a new buzzword in that space every week, and for that particular problem, it's what we call the harness. So with our MCP server, you can create a harness for your coding agents so that they never go off rail. An example of that is you can say, hey, I don't want you to ever create a new exception. I don't want you to ever call that database, but you should call that cache instead, etc. And so the possibilities of that are limitless. What is the MCP server? It's quite simple. It's just an MCP layer, model context protocol, on top of our APIs. It's our APIs that retrieve data from Datadog, so metrics, traces, logs, etc., as well as governance APIs to create monitors, to trigger incidents, or to create dashboards. And so Datadog MCP server allows AI agents to securely interact with all that live data. Now let's look at a couple of examples. First, to set it up, it takes only 30 seconds. You type the command to download it, then you type /mcp, and it will go through the authentication flow. And you don't need to manage any type of API key. It goes on the web, and you authentify through OAuth. Now, what's great about MCP is that we've done enough prompt engineering that the AI agents know exactly which tool to call for the questions, the prompts that you ask. So let's see a couple of examples. The first one is just my support team has told me that there has a bunch of errors on my website. So I'm just taking my favorite coding agent, Claude, and I'm just asking, hey, I've heard of some errors. Can you look into that? Claude will look at error traces, error logs, and then come up with a solution. If you're happy with the reasoning of it, you can just say, can you create a fix, a draft PR? And then if you're happy with the code, you can just push it. And you can see the dev never left its development tooling. If we look at another use case on the governance side, we can run a quick audit of our monitors. So we can ask Claude, tell me which monitors are unused or not looked at by most teams. Just queries it, and then it gives me a list of all the teams and the monitors that they are not using. Now, if I have the Slack MCP, I can just say, can you ping these teams and just ask them if they're OK with me deleting these monitors? Wait for the answer, and automatically, if they say yes, delete them. Final example on the optimization side. I can also ask Claude to look at inefficiencies of my compute. So I can say, can you find the hosts that are basically wasting resources and are underutilized? It looks at infrastructure monitoring data and cloud cost monitoring, and it just gives me a list of all the hosts that are basically running idle on CPU. Then it can recommend me how to fix it, probably by right-sizing these hosts or right-sizing the containers. As you can see, now I have a list of each host and estimated savings. Last but not least, let's say that each of these analyses, I want to share them with my teams, with my managers, with my peers. I can simply ask Claude to create a notebook out of them, and then a notebook will just be created on Datadog, for example, here for the cost use case. And then you can still work on that notebook. You can edit the graphs, etc., to further complete your analysis. I'm sure you're all thinking about what you can do with our MCP server right now. And again, the possibilities are limitless. So I really encourage you to try it. And with that, I'll welcome Yrieix back on stage to close this keynote. Thank you.
Thanks, Hugo. And I would say even more, thank you for Mark and Adam for those amazing, really customer testimony here. So what we were very excited to show you here is actually still kind of the tip of the iceberg. There is the latest innovation we just showed you, but there is much more we're actually working on top of the Datadog platform. So that slide is a slide I see a lot of people taking pictures because this is pretty complete. This is almost everything we do here at Datadog, how we bring everything of that together on top of the platform. So I won't go through each of those. We're getting to the end of the keynote here. But I just want to just put it there so you can see the breadth of the solution we actually do support, how we bring together and break down those silos between operation, DevOps team, between data engineers, the product designers, developers, security teams, but also how we bring incident response, the FinOps team, and really your business users. So we're doing much more into all of those areas, and we're really seeing that bringing value to our customers. So this is really where we are, and that goal is really to close that kind of end-to-end decision, action, and automation platform, closing that loop, so then we give you the most value from your investment here. This is exactly also, as a reminder, what will be available with the UK data center, so available in the UK regions for you to be able to use. What I want to do here to really kind of close is more looking a bit forward. Where are we really heading? So Hugo talked about that kind of dev cycle kind of loops. I talked to you about the production one. When you have good observability practice, and that really helps you inform both. You understand what's happening on the development side, and then you can better understand and troubleshoot anything that happen in productions. And you can, that equilibrium, because those two have to really kind of run or turn together, this is really how you're going to be able to go on to scale. But if you think about that, in the age of AI, this is going to have a pretty massive impact on this. If I just take a quick step back here, when you look at Datadog, we've really kind of helped do the transformation from like monitoring to observability. We really broke down the silos to bring dev and ops together, and that's really at the beginning, years ago, when the cloud was still kind of emerging. Now, with code development really accelerating in order of magnitude, we're talking about 100x faster the ability to code and to develop with like AI coding solutions. The problem we solve is becoming even more important. And this really going to take us from the edge of observability to the edge of autonomy. When we say autonomy here, we're really talking about how we want to validate your different systems, your apps, your agents. And with that increase of AI coding, it actually rely more on like probabilistic AI models that really are even harder to test and really to predict. So that is really where we want to go and help like maintain the security and the safety of those applications. When we want to make sure your agent is actually aligned with your intent and the different constraints you put on top of those to give you the control, making sure you have the right mechanism to control what those agents are doing, but also automate kind of the feedback loop. And really at the end, we want to make sure we're able to go and help you verify changes which are generated that really bring the expected business outcome. So this is really where we are heading. We're heading toward that long-term vision to be able to deliver that true autonomy across development, operation, and security, and really helping you harness really the power of AI to really move faster, deploy very complex technology, always with confidence. And this, we've seen you show you some of this. We're really just getting started.